So good afternoon, everyone. We're in the home stretch. My name is Andy Young, and I realize everyone's going to the luau tonight, so I included lots of pictures. It should be pretty easy to follow along. But I'm here to provide sort of a small business case study for what I think is possible given the changing roles of process control. I'm not involved with an industry in transition per se, at least at our own company. I didn't inherit any legacy technology. But we've used a lot of the nascent technologies that are arriving, as we speak, and we've kind of packaged them together. So I have a bit of a narrative I'll go through in this presentation to share some of that with you. And my intent is I really want to show you, not only the details of implementation, but to provide the confidence that you can unlock, some functionality from these technologies, which are, in a lot of ways, unprecedented. So like I said, I work for Pioneer Energy. We're based in Lakewood, Colorado, which is almost like Denver, so we could say Denver. But we are a small company. We have 25 employees right now, and we are vertically integrated. We've come a long way in 5 or 6 years. We have a heritage as a research industry. So our company president was involved pretty heavily in NASA. He wrote some mission plans to Mars, and he's on the National Geographic Channel every now and then. But he realized some of the space technology that he and others had developed was applicable to the domestic energy industry. And he and our CEO set out on a mission to kind of innovate in the domestic energy industry to not only increase production, but to change people's minds about what is possible. And so that's what I'm currently involved in. Our global scope, the big picture is we want to harness cheap carbon feedstocks, and through various means of processing and separation, we would like to convert those into drop-in gasoline alternatives. And so you can visualize this as a bit like the 7-Eleven model. Maybe every neighborhood has their own fuel generation plant, and when you swing in with your space car, you could fill up on CNG, or maybe you want some dimethyl ether for your little space mobile. But that's kind of the big idea that we're working with here, and it represents bigger themes of modularity and mobility and localization and regionalization. And we've leveraged process control as kind of a route to take on this journey. Currently, we have our first product deployed in North Dakota, Montana, and Colorado. So you can see we're kind of regionally focused in the Rocky Mountains, but we're looking to grow beyond that, of course. So this is what we build, and this is designed to address that big picture on the previous slide, which is in itself a cheap carbon feedstock. We call this the flare catcher, and what you're seeing is a totally integrated mobile gas plant on wheels. The joke is it's mobile because it has wheels, and so you can see the wheels in the back. But we literally do drive onto oil and gas sites with our solution. I don't want to get too technical because this is a presentation about process control, but you can see a couple key features here. We have our main processing skid. You see a feed line coming in off the ground. That's bringing in that natural gas that's diverted away from the flare from the previous slide into the front end of our system for separation. So some pretty basic unit ops: compression, dehydration, refrigeration, separation. And all of a sudden, we're making 2 products in real time. The primary product goes into the large white tank on site. We call those natural gas liquids. It's mostly propane and butane, things you're familiar with. The other product that we're making in real time is leaving through the second pipe on the ground towards the aft end of the trailer. That is pipeline quality natural gas. It's low BTU methane, it's dewatered, it's ready for prime time. So we can do compressed natural gas with that, we can do power generation, liquid natural gas, whatever any kind of methane applications people have, maybe even on-site chemistry eventually. But that's another kind of real-time product. So we're taking this waste stream, and in real time, we're converting it into 2 value streams. And this is all being done, as you'll see, without anyone on site. There is one detail on the photograph that sort of betrays that narrative a little bit. So there's a porta potty on site. And this, I think, represents a lot of our initial anxiety about running these things wirelessly. So on the back end of the trailer, you'll see some antennas. We have a couple different flavors of communication protocol, but the underlying technology is a wireless 3G VPN modem. And Of course, we got through the proof of concept and it works great and everything else, but it's another thing to do it on a client site. And so this is our first installation in North Dakota from 2.5 years ago. But this is what we do, and the challenge was to design a single system that could really be deployed anywhere, because the problem we're trying to solve is this. This is a heat map from a NOAA satellite that is measuring basically heat density in watts per square meter. This is a particular visualization that Harvard generated. But the takeaway is that the radius of the circles are proportional to the amount of heat being emitted from point sources, with the conclusion being that these point sources are representative of natural gas flaring that's happening globally. So here's our cheap carbon feedstock, and here's also kind of not only the size of our market and our opportunity, but kind of the technical challenge that we're up against as a hardware and processing manufacturer. So it is a big problem. And again, what we really want to do is address these natural gas resources at the source. In the United States, flaring isn't as big of an issue as it may seem visually on the map, because we have pipelines. And pipeline infrastructure is kind of the primary method to address this associated gas from these well sites. Well, in all these other developing countries, even countries with advanced infrastructure, pipelines can be geographically challenged. They can be too costly. Sometimes it can simply be time limited, to where a producer would want to start, producing oil from the well before a pipeline could ever get there. So our technology is designed to kind of go around the infrastructure problem. It's designed to really replace the infrastructure. And in doing so, it presents some technical challenges, as you can imagine. So when we were thinking about what to do about this problem, we had to consider really all of these parameters when we were designing this machine. The first one being operations. How are we going to do this? Well, one of the first conclusions we arrived at was we cannot have these machines staffed 24/7. It's just not viable. You have a real challenge to find someone who's, one, willing to be there, but two, has the expertise to work on this machinery, and then third, who's going to operate it. So that was really the biggest question we struggle with. But everything else is relevant too. The adaptability. We are really promoting the ability to put this machine on any oil site in the world and have it run on any inlet pressure, any feed composition, really any ambient condition, whether it's very hot or very cold outside. So this wasn't as simple as just running a pump station. We had to have some really sophisticated process control integrated into the machine itself in order to address this opportunity. Next was data. Do we have the data available in real time? Do we, put in, regional historians that can then mirror that data back to headquarters? How's that going to work? Then there's the concern of safety. So we're processing natural gas. There's some very real safety concerns here, and we can't take shortcuts on that end either. Security, of course. Data security is huge. Hackers have very explicitly targeted the energy industry as a nice big goal of theirs. So that challenge hasn't gone away either. Then we have, like any company, client relations. We have to keep them happy. We have to justify our case to be on site and help them solve their problems. And then, of course, we have internal and external stakeholders as well that we have to answer to. So what you're seeing on the back of that tractor trailer, has to address all of these concerns. And I feel like these are concerns that everyone has to address in their industries. And your answers and solutions may be different, but it's a necessary exercise. And we had the luxury of starting with a clean sheet. But the challenges exist regardless of how you arrive at those solutions. And one of the big components of process control, and I'm really happy the other two speakers addressed this, is the personnel. I heard Janice mention yesterday Kia has some lights out factories. And I guess that sounds attractive to some people, and if they're technically capable of achieving that, then hats off to them. But we're not there yet. We still employ people, and they provide a really big role in what we do. I think just recently Facebook divulged that they have human editors involved in their news recommendation engine, and some people took exception at that. But I think that's a really interesting sort of paradox in that, we're talking about automation and a lot of people feel like their jobs are threatened, or maybe it's a job replacement approach. But in reality, you need higher quality people to pull this off. And that's, it's a bit counterintuitive, but the end result is your machines and your solutions can be a lot more functional, a lot more profitable than they could have been in the past. So to address the operations question from the previous slide, we made a very fundamentalist decision, and that is operators will operate the machines and field service technicians will work on the machines, and those are two very different types of people. Our field service technicians are local to the hardware, and our operators sit at headquarters, so they're right next door to me and the engineering and design offices. And so as they're operating the machines from headquarters, we as engineers also get access to that data and information. And so again, being vertically integrated, we can learn lessons from operations as it's happening in real time. And this entire just concept, it would not have been possible 5-10 years ago, given the existing technology. The other decision we made, which I just touched on, is to combine departments that are typically exclusive from one another. So we have a lot of people bleeding between these core competencies: design and fabrication. Fabrication happens in-house. Process control, operations, all of those people, if they're not the same people, they're constantly bumping into people who are performing these other job functions. And it's really fun. I mean, it's collaborative. When we have a project going, everybody's speaking the same language and having the same thoughts at the same time, because we're trying to really kind of saturate everyone with the data and with the ideas of the process controls that's happening. And then of course there's hiring. So I've had to do a lot of this myself. The people that we hire, we don't have any choice but to hire people with multiple skill sets. There's the jack of all trades, master of none moniker, but in reality we found it's actually faster for someone who knows a little bit about a lot of things. You don't necessarily have to go consult with IT, and I use that because we don't have an IT department, so we don't have to consult with them. We just do it. You have to connect those things. You don't have a choice, and so they get connected, and then you address the next problem as it happens. And this is just kind of one of those cultural things like we've addressed before as well. And so the hiring process is very important. It's as important as the technology selection. Finally, use contractors. I mean, you don't have to reinvent the wheel every single time. For instance, I'm engaging some graphical designers to spruce up our HMI screens a little bit. And that's okay. They don't have to be process engineers, and I'm certainly not a graphic designer. So there's some nice services that can be had outside of your organization for reasonable cost to really kind of make the entire project go forward. So our approach to solving the design challenge that we're up against as process control experts, I identified 3 kind of core concepts that we've used and that have gotten us pretty far. So the first one is atomicity. Pick the best tool for the job. If you want a data historian, pick a great data historian. If you want a great controller, choose a great controller. You don't have to get locked into a single platform. Now, that may not have been true 5 to 10 years ago, but now I think there's a lot more optionality in the marketplace. So choose the best tool for the job. That way you don't have to revisit that part of your solution. The second idea is, of course, connectivity. Network it. If it can't be networked, find something that bolts onto it that will allow it to be networked. You have to connect these devices because a device that can't be communicated with effectively doesn't exist. For instance, the 18,000-gallon storage tank that we have on site. Initially, the idea was, okay, well, the field techs are going to be visiting the site. When they visit the site, they'll do their repairs. They'll take a tank reading. They'll call it in. We'll write it down, and then we'll have our tank readings. Well, that lasted for about a month, and then we didn't have tank readings, and then we didn't have a great idea of our production numbers. So we had to, source a wireless, nice little embedded analog to digital converter, connected it to the magnetic collar on the level sensor, and all of a sudden we had a level reading that we could actually communicate. So you have to connect your devices. It's just not an option anymore. It's not easy though, so don't let me give that impression. And then finally, and most importantly in some ways, is the glue. What glue are you going to use to access your hardware, to access your information, to access your connected devices? This glue can take any form, really. It can be a vendor-specific platform. It can be maybe a particular programming language that is, familiar inside of your organization. There are a lot of options. It could be certain communication protocols. Maybe your entire plant is Ethernet IP or something. But whatever the glue is and whatever form it takes, you have to be able to roll up all of your assets into a single global view to even begin to manage them. I mean, you can see how this is getting complex pretty quickly. So the glue is important. And then finally, the tools that kind of comprise the solution that we're talking about here. Wireless technology is absolutely critical to our solution. I remember making promises to clients for weeks and months as we did our initial marketing pitch. And they would say, well, how are you going to do this? And I'd say, don't worry, we're going to run it from headquarters. And I had no idea how we were going to do it. But I worked with a vendor very closely who provided us some cellular VPNs. More importantly, they trained us on them. And so with that, we get the security and the availability for our machines, which is just, again, it's fundamental. It's not optional. On top of that, though, we've taken a very strict conservation of data approach. So we're going over 3G networks. I don't want to bog down the links. I don't want to spend more money on data that's not important. And what that does is it keeps the airways open to where if you need to dive in with another secondary protocol or some other redundancy approach you put in, you can do that. Your machine's available. So conservation of data, I think, is really important, and you can work with your vendors on that as well. Mesh networks is a neat little technology we use on site to incorporate wireless sensors and things. Smart programmable PLCs or controllers, that's another really kind of core component of what we use for our solution. Open standards, APIs, SQL, CSVs, things of that. And I don't mean open source here. I mean standards that have their interfaces published and that are simple and easy to use and easy to be understood and not proprietary. So you can share among all of your components that you've selected from your atomicity approach to connect them all, not only have them physically connected, but have them communicating with one another. And then finally, the communication protocols involved are many and multiple, and in many ways, I think this is becoming the approach for redundancy. You can't run, well, I guess you could, but we're not running 2 wireless connections. We're running multiple protocols on that wireless connection. And so just the core concepts of process control are still there. You still need, availability, redundancy, but I think in some ways the techniques to achieve those concepts are changing as the technology changes. So let's just, cement some of these ideas. And again, I hope these concepts are broadly applicable to whatever solutions you're trying to, or whatever problems you're trying to solve, really. So here's a single machine of ours. It has a couple components. It has a controller, some I/O, wireless access point, and some wireless field sensors. And then what do we do with our machines? We put them out into the world. So we can multiplex our machines on client sites to address their needs. But again, a machine sitting on a client site is completely useless. So we have to connect them back to some physical location. We've chosen to go with the data center. Data centers are great, by the way. They can take airplane hits on the roof, and they have 7 redundant networks and 2 substations and 30,000 gallons of diesel on site. And they can keep your computers running, at least at this location. From there, then we get to do something with the data. So we have a server that's local to that hub communication point. We're running a database historian. We're running data analytics. We're running a great mobile HMI called Groove, because really the phone's the new HMI. So we have that functionality. Then at headquarters, we connect into the hub as well. Our OPC server runs there. We run an HMI from Opto22 at headquarters, and file sharing and whatever from there. So this is kind of our core operations model here. So our operators are able to patch in And then again, we've put a nice little web server front end so our clients and stakeholders can log in and see what we're doing in real time as well. And they love that, by the way. These are simple little steps once everything else is in place to give your client access to the data. Even your internal clients or your internal business units, they love this stuff. It's really cool. And then finally, we use design and engineering internally to access this data as well, because when we have problems in the field, ultimately it's a design issue, and we want to roll those solutions back into the next build. And so from here, now our data is remote, it's secure, it's wireless, it's being managed, it's being analyzed, it's made available, and now it's accessible. And now anyone can access this in a somewhat structured way. And so these are the specifics of the concepts that I've been working towards up to this point. I think this is the new look to process control. And it's complicated intentionally. I mean, my office's walls are covered in whiteboards, and it's all circles and arrows connected because it's such a visual process anymore to manage all the different technologies. But the end result is really, really powerful. So the impact of our approach is this. We have field units all over the Rocky Mountain region, and we're pretty excited about that. But it all boils down to process control. I mean, it's really a process control machine on wheels, and it's pretty exciting. Here we are in Colorado on the left. We have Montana and North Dakota hanging out on the side of the road. Our machines are more reliable than the semis that pull them sometimes, so that's a good thing. And so this is just some performance metrics to date. These are a couple weeks old, so almost 400 million cubic feet of gas processed that would have otherwise been burnt or flared. Of that, we've extracted 1.4 million gallons of natural gas liquids products. This is our production scale over time. And those liquid products that I just mentioned represent almost 8,000 tons of CO2 diverted from being combusted. That's equivalent to taking 1,500 cars off the road in the United States for a year. So, you know, it's an impact. And again, this technology would not have been available were it not for all of the technologies that we're talking about this week. And they can be confusing, they can swirl, but when combined, it really is a good thing, and it's worth the effort. So our lessons learned are that we've arrived at a secondary product. We're now going after the fugitive emissions from the tanks themselves with their project that we're calling the Vapor Catcher. Same idea, remote, distributed processing solutions, globally available, because we've got the data going to the right places. Thank you.